Welcome to the homework portal. So as suggested or as told in the class that we will be solving problems. So this problem is for Monday, that is on 2nd September 2024. Okay, and I have set the timer for 8 minutes because the total marks here 2 plus 2 4, 4 plus 2 6 plus 2 8 minutes. So we need to solve this problem in 8 minutes. Let us try doing it. I do not know whether I will be able to do it or not, but let me try it out. Okay, let us begin with. So I hope you all have got the solutions correctly. If not, please look into it so that you can verify your solutions and tomorrow you can submit the paper. Right. So first question, an athlete trains by dragging a heavy load across a rough horizontal surface. It means what? There is a friction over here. The athlete exerts a force of magnitude F. There is a force which is pulling this object at an angle of 25 degrees to the horizontal. Once the load is moved at a steady speed, so you are moving this at a steady speed. Okay, what do you mean by steady speed? When you say steady speed, let me just increase this font here. Right. Okay. When you say steady speed, which means this force, the applied force over here should be equal to the frictional force because there is a frictional force. So net force acting on it is equal to 0. Okay, F net is equal to 0. Okay, the average frictional force acting on the load is 470 Newton. So here the frictional force is already given as 470 Newton over here. Calculate the average value of F that will enable the load to move at constant speed. So now what is given is you need to find out the value of F. Okay, but nothing else is given. So if this force is equal to 470 Newton, this force should also be 470 Newton. Why is it 470 Newton? The reason is because only then the net force acting on this object will become 0 over here, right? So therefore, and hence this is 470 Newton. Now what we do is, if this is my applied force F here, I know that F cos 25 is equal to F applied, which should be equal to 470. So I can find out the value of F here, which should be 470 divided by cos 25. When I do this, I already calculated this value. So this comes out to be something like around 520 Newton. You can use your calculators to find out this value. Okay, let us move on to the next one. The load is moved a horizontal distance of 2.5 kilometers in 1.2 minutes, 1.2 hours. So this is distance is given and time is given. Calculate the work done by the load or work done on the load by the force F. So he is asking you what is the work done on the load by the force F. Now see, though the force F is acting over here, when you say you are moving a given distance like this, now which force should you consider? You should apply this force over here, okay, not this force. Okay, because this force is divided into the horizontal component and the vertical component. You should look at, okay, where is the work done? Is the work done along the horizontal or along the vertical? If you read this question here clearly, it says it's moved a horizontal distance. That means you are doing a work done for a horizontal distance. So therefore, now so you should have F horizontal multiplied by the displacement, which is 2.5 kilometers, should be equal to work done. That's what you should have. Now what is the F horizontal over here? F horizontal is nothing but 470 Newton. Why 470 Newton? Because it's already given here, right? 470 was the frictional force and this should also be 470, which we have already considered, right? So therefore, so this should be 470 multiplied by, what is this here? Time takes, so distance is 2.5 kilometers. 2.5 into 10 to the power of 3 should be your work done. So let us calculate this value. This value, if you calculate this, it comes out to be around 1.2 megajoules. You can use your calculator to get this one done over here, which is equal to 1.2 into 10 to the power of 6 joules over here. Okay. Then next question. The minimum average power required to move the load. Minimum average power. So anyway, you are looking only to move it along this direction, not vertically upwards. You already got the work done. You need to find out the power. How do you do it? Power is equal to work done divided by time. Work done is already got it as 1.2 into 10 to the power of 6. And what is the time taken? Time taken is already given to you, which is 1.2 hours. So put it as 1.2 hours. But I want in terms of joules. So what I do is I write this as this 1.2 and this 1.2 goes away. So you can write this as 10 power 6 watts divided by hours. I need to convert this, which should be 3600 seconds, right? When I do this, so and calculate this value, I get this as something like around accurately as 278 watts. This is the value that I get over here. But if you look at this, so in all the questions, see there are two significant figures here. Okay, so here there are two significant figures, everywhere it is given in two significant figures. So what you can do is you can either write this as 270 watts or 280 watts, because you see this is also two significant figures, but anyway it is 278 over here. The most appropriate answer would be to write it as 280 watts because we have approximated this. Right, let us move on to the next one. The athlete pulls the load uphill at the same speed as in part A. Now instead of moving the object horizontally like this, what he does is he moves it uphill, which means what? He's going to have an uphill, he's going to move it like this. Explain in terms of the energy changes with the same speed. So he is having the same speed over here. Explain in terms of energy changes why the minimum average power required is greater than in B. Okay, so therefore it should be larger. So whatever average power you need, whatever power you are going to pull it over here, this should be larger than whatever you have pulled over here. This is what has been asked. So how do you justify this one? See, when you pull the object upward like this, what's happening over here? See, you are going to pull it against the horizontal and you're going to pull it in addition to the friction, you're going to pull it, say the same surface, right? So there is a frictional force, okay, which is dragging it down likewise. At the same way, you also have a gravitational pull, right? You're going to pull it upwards. So there's also a gravitational pull. So you need to spend energy on overcoming the friction plus overcoming the gravity, right? So therefore you need to apply a larger pull. Earlier what it was? It was only due to the friction, no gravity there, because everywhere you see the gravity was one and the same. So you are not doing any work against the gravity, right? So but here it is not so. You need to do for both of them. So as a result of this, okay, the power that you require is much higher. Now what do you write here? That is what is important. So okay, what do you write over here? You need to write, it's for 2 marks over here. Just a minute, let me take it up. Okay, it's for 2 marks over here. So you need to say that in case of uphill, so for 1 mark you need to write, that gravity acts apart from friction. This will give you 1 mark. You have justified the reason. Hence, your concluding remark. Hence, energy or power required will be more than the horizontal to pull the object. Okay, if you write so much, you will definitely get all the 8 marks. I think we have completed this within stipulated time. Let us move on to the next video.